We all know water is essential, right? I mean, we need
Wow.
it to survive, but how often do we really think about its journey? From a tiny raindrop to, a vast ocean, water goes through so much.
It really does.
Today, we're going on a deep dive into that very journey.
Yeah.
We're talking the water cycle, and then we'll be exploring the hidden landscapes of the ocean floor using excerpts from Fundamentals of Physical Geography.
Awesome.
Ever wonder what lies beneath the
Oh,
surface?
yeah, all the time.
Did you know there are mountains down there that are taller than Everest?
It's incredible.
Get ready for some serious aha moments.
It's fascinating when you think about the water cycle. It's this incredible balancing act,
hmm
a system that's been working for, well, billions of years, yet we often just overlook its importance.
Totally. It seems so simple, right? Water evaporates, it forms clouds, falls back down as rain or snow,
Right.
and then the cycle just repeats. But as our source points out, 71% of Earth's water resides in the oceans. And this constant movement is vital for life, for climate regulation. It's everything.
It is, and that's where the aha moment hits.
Yeah.
This seemingly basic cycle is connected to the very real water crisis that we're facing.
Right.
And it's our increasing demand for water that's really putting a strain on this delicate balance.
Yeah, it really makes you think twice about how much water you use, right?
Absolutely.
Okay, so we've got this image of water constantly moving, but where does it all end up? The ocean,
The oceans, yeah.
which are way more than just a big blue expanse. The ocean floor is like a world unto itself,
It is.
a hidden landscape with features that rival anything we see on land.
It's true. Think of it like this. We're only just beginning to explore the vastness, the complexity of the ocean floor. It's like discovering a whole new planet right here on Earth.
That's crazy.
Well,
Our source breaks this underwater world down into four main divisions. Let's start with the continental shelf. It sounds kind of like a boring term, I guess.
Yeah.
But it's actually this incredibly rich, vibrant area.
It is.
Essentially, it's like the submerged edge of a continent. It gently slopes out from the coastline.
It's teeming with life.
Yeah.
And a major source of, well, things we depend on, like fossil fuels, which, if we connect this back to the water crisis, it's a bit of a double-edged sword, wouldn't you say?
Hold on. Extracting fossil fuels from the ocean floor, that's contributing to the very water crisis we're talking about. How does that work?
Well, the process of extracting and transporting those fuels, it can have detrimental effects on marine ecosystems
I see.
and water quality. And of course, burning those fossil fuels contributes to climate change, which further exacerbates the water crisis through things like altered precipitation patterns and rising sea levels.
Wow.
It's a complex issue. There are no easy solutions.
So the water cycle, the ocean floor, and the water crisis are all intertwined. It's not just about conserving water in our homes. It's about understanding these larger systems at play. Okay, so we've walked out onto the continental shelf. The water's getting deeper. What happens next? We hit the continental slope, right?
Exactly. And here's where things get dramatic.
Okay.
The shelf suddenly drops off, plunging steeply down to the deep ocean floor. Imagine diving down, the sunlight fading, the pressure increasing. It's like entering a whole new world.
Yeah, this is where, like, those documentaries about deep sea creatures come to mind.
Oh, for sure.
Okay, we've plunged into the depths. Now we reach the deep sea plane,
Yeah,
which, according to our source, is surprisingly flat.
it is. It's a bit counterintuitive, but those plains are some of the smoothest surfaces on Earth,
Really?
covered in fine sediment, the result of millions of years of particles just raining down from above.
Hmm.
Makes you wonder of the history buried down there, doesn't it?
Totally.
Yeah.
Okay, last stop on our underwater tour, the oceanic deeps, those mysterious trenches. I'm picturing colossal squid and bioluminescent creatures. These are the deepest parts of the ocean, deeper than Mount Everest is tall.
It's true. And they're not just deep and dark, they're geologically active. We're talking about the meeting points of tectonic plates where one slides under the other. That process creates these incredible trenches, and it fuels volcanic activity.
Wow, so the Earth's crust is literally being reshaped down there.
Yeah.
I'm starting to see how all of this connects. From the water cycle to the forces that are shaping the planet, it's like a chain reaction.
It really is. And we haven't even touched on the smaller features yet.
Oh, okay.
The mid-oceanic ridges, seamounts, those incredible underwater canyons.
Hold on, we can't just gloss over those.
Okay, sure.
I'm picturing those incredible images from those nature documentaries.
Right.
Tell me more about these smaller features.
Well, for example, those mid-oceanic ridges are actually vast mountain ranges. They're formed by volcanic activity. And some of their peaks are so high that they actually rise above the surface, forming islands.
Mm.
Think Iceland. It's actually the tip of a massive underwater mountain range.
Iceland is a mountain peak.
Yeah.
Mind blown.
I know, right?
All right, what about those seamount? They sound like something out of a Jules Verne novel.
Yeah, they do. Imagine, like, underwater mountains, some towering thousands of meters high, but never quite reaching the surface. These hidden giants create unique habitats for marine life, and they play a role in ocean currents. They're like oases in the deep.
And then there are underwater canyons, like the Grand Canyon, but submerged.
Yes, carved by powerful underwater currents over vast stretches of time. They're a testament to the power of erosion,
Wow.
even in the depths of the ocean.
It's amazing to think about those forces that shape these landscapes, both on land and beneath the waves. Our source also mentions guyodes, which are flat-top seamounts. How did they get that way?
Well, imagine a seamount that once reached the surface, forming an island. Over time, waves and weather eroded its peak, flattening it out.
Oh, okay.
Eventually, geological processes caused it to sink back below the surface, leaving behind a flat-topped mountain beneath the waves.
So they're like ancient sunken islands.
They are.
That's incredible. And finally, we have atolls, those beautiful ring-shaped coral reefs. I've always wanted to visit one.
Oh, yeah. They're stunningly beautiful, but also incredibly fragile ecosystems, unfortunately. They're formed by coral growing around the rim of a submerged volcano, and they're facing serious threats from climate change and rising sea levels.
Wow. Even in the most remote parts of the ocean, we're seeing the impacts of our actions. It really drives home the interconnectedness of everything. So we've explored this incredible 3D world of the ocean floor, but what about the water itself? I mean, it's not just one big uniform mass, right?
Absolutely not. And this is where things get even more interesting.
Okay.
The temperature and saltiness of the ocean, what we call salinity, vary significantly depending on where you are.
Okay, let's start with temperature. If you've ever gone swimming in a deep lake or the ocean, you've probably noticed that the water gets colder as you go deeper.
Right, that's because of the thermocline. It's a zone where the temperature drops rapidly with depth. It creates these distinct layers in the ocean, like a giant layer cake.
So the ocean is layered like a cake. That's a great way to visualize it.
Exactly. The top layer is warmer and sunlit, while the depths are much colder and darker.
Right.
And this layering, it's not just a fun fact, it has a huge impact on ocean currents and marine life.
Wow. Okay, now on to salinity. We all know seawater is salty,
Yeah,
but did you know that some parts of the ocean are far saltier than others? Think about the Dead Sea. It's so salty you can practically float on the surface.
exactly. It's a great example. Salinity is affected by a few things. Evaporation,
Right.
freshwater inflow from rivers, and even wind patterns.
So places with high evaporation rates, like the Mediterranean Sea, would have higher salinity, while areas with lots of fresh water flowing in, like the Baltic Sea, would have lower salinity.
Exactly. It's all about the balance between freshwater input and water loss through evaporation.
Hmm.
And just like with temperature, these variations in salinity play a huge role in ocean currents. In fact, the combination of temperature and salinity differences creates something called thermohaline circulation,
Yeah.
which drives a massive global system of currents that influences climate patterns around the world.
So we've got these differences in temperature and salinity creating these massive underwater conveyor belts.
You got it.
That's incredible.
Yeah.
It seems like we've only scratched the surface here.
We have.
What's next on our deep dive?
Well, now that we've explored the ocean floor and the variations within the water itself,
Right?
it's time to see how it all moves.
Okay.
We're talking waves, tides, currents, the dynamic forces that shape our oceans.
All right, we've covered a lot of ground, literally, from the water cycle to the ocean floor to temperature and salinity. We've seen how it's all interconnected, but it's still a bit static, isn't it?
Yeah.
Let's get things moving. What can you tell us about waves, tides, and currents?
That's where the ocean really comes alive. We're talking about the constant motion that shapes coastlines,
Right.
influences climate, and even impacts marine life.
Let's start with waves. You see them crashing on the shore.
Yeah.
But have you ever thought about what causes them?
Honestly, I've always just taken them for granted. I know they're powerful,
Yeah.
especially during storms,
Right.
but I don't really know how they form.
It's all about energy transfer. Wind blowing over the surface of the water creates friction,
Okay.
and that friction transfers energy from the air to the water. The stronger the wind, the longer it blows, the more energy gets transferred, and the bigger the waves become.
So those massive waves that you see surfers riding, those are created by strong winds blowing over vast distances.
Exactly. And then, as those waves approach the shore, they start to feel the bottom. The friction from the shallower depths slows them down, causing them to bunch up and eventually break, releasing all that pent-up energy.
It's amazing how much power is contained in a single wave.
Yeah.
Okay, so wind creates waves. What about tides?
Those always seemed a bit more mysterious to me. What causes the ocean to rise and fall like clockwork?
Tides are all about gravity. The gravitational pull of the moon, and to a lesser extent the sun, acts on the Earth's oceans, creating bulges of water.
Wait, so the moon is literally pulling the water towards it?
It is. The side of the Earth facing the moon experiences a stronger gravitational pull, causing a bulge of water, which we experience as high tide. And here's the interesting part. There's another bulge on the opposite side of the Earth.
Why would there be a bulge on the opposite side if the moon is pulling on the other side?
That's because of inertia. The Earth and the moon are actually rotating around a common center of gravity.
Yeah.
This rotation creates a centrifugal force that pushes water outwards on the side opposite the moon, creating a second bulge.
So we get 2 high tides per day because of the moon's pull and the Earth's rotation.
Precisely. And between those bulges, we experience low tides.
Okay.
The timing and height of the tides can vary depending on the location, the alignment of the sun and the moon, and even the shape of the coastline.
Wow, so it's not as simple as just the moon pulling on the water. There's like a whole dance of forces happening.
It is.
Okay, last but not least, let's talk about currents. These are like giant rivers flowing through the ocean, right?
That's a good way to visualize it.
Mm.
Ocean currents are driven by a combination of factors,
Mhm.
including wind patterns, the Earth's rotation, and as we discussed earlier, differences in water density.
So those differences in temperature and salinity, which we talked about before, they actually play a role in driving these massive currents.
They do. Denser water, which is colder and saltier, sinks, while warmer, less salty water rises.
Oh, okay.
This creates a continuous circulation pattern.
So it's like a giant underwater conveyor belt moving water around the globe.
Exactly. And these currents have a huge impact on climate.
Okay.
They transport heat from the tropics towards the poles, helping to regulate global temperatures. Without these currents, the tropics would be much hotter and the poles would be much colder.
It all circles back to that interconnectedness we keep talking about.
I know, it's fascinating.
The water cycle, the ocean floor, temperature, salinity, waves, tides, currents, it's all connected.
It really is. And these connections highlight the crucial role that the ocean plays in regulating our planet's systems.
Okay, so we've gone from this seemingly simple act of wind creating waves to this intricate dance of gravity and density driving tides and currents. What's the key takeaway for our listener here?
I think the most important thing is to understand that the ocean is not just a static body of water. It's constantly in motion. And these movements have profound effects on our planet's climate, weather patterns, and even the distribution of marine life.
It's a reminder that we need to think about the ocean, not just as this beautiful backdrop, but as a dynamic force that shapes our world.
Absolutely. And this understanding is crucial as we face challenges like climate change and the need to manage our ocean resources sustainably.
So how can we connect what we've learned today back to the water crisis?
Yeah.
We talked about how human actions are impacting the water cycle,
Right.
but how did these movements of ocean water fit into the equation?
That's a great question. The ocean plays a huge role in the water cycle through evaporation, precipitation, and the movement of currents that distribute fresh water around the globe. As we alter the ocean's chemistry and temperature, through pollution and climate change, we risk disrupting these delicate balances, which could have severe consequences for freshwater availability and weather patterns.
So protecting the ocean isn't just about saving marine life. It's about ensuring the stability of the entire planet's water system.
It is. And that brings us back to the importance of individual actions.
Yeah.
Every drop of water we conserve, every effort we make to reduce pollution, combat climate change, contributes to protecting this vital resource.
This deep dive has been incredible. I feel like I've gained a whole new appreciation for the complexity and the power of the ocean.
Yeah.
It's so much more than just a big blue expanse. What about you, listener? What stood out to you the most?
For me, it's the interconnectedness of everything. How something as seemingly simple as wind blowing over the surface can create massive waves that travel across entire oceans, impacting coastlines thousands of miles away. It's a reminder that we're all connected, and our actions have ripple effects throughout the planet.
I completely agree. It's mind-blowing to think about how the gravitational pull of the moon creates tides, or how subtle differences in temperature and salinity can drive these massive currents that regulate our climate.
It really highlights the delicate balance that sustains life on Earth.
Okay, we've covered a lot of ground here, but I feel like we're just scratching the surface.
We are.
There's so much more to learn about this incredible planet we call home.
There is. And I think that's what makes exploring the natural world so fascinating.
Yeah.
There's always something new to discover, always another layer to peel back.
So where do we go from here? We've explored the water cycle, the ocean floor, and the movements of ocean water.
Right.
What's the next frontier in our understanding of this essential element?
Well, now that we have a good grasp of the physical processes at play, we can dive deeper into the biological world of the ocean. We can explore the incredible diversity of life that thrives in these underwater ecosystems, from microscopic plankton to giant whales.
That sounds fascinating. I'm already picturing colorful coral reefs, bioluminescent creatures, and maybe even a few deep sea monsters lurking in the depths.
I think we'll uncover even more incredible insights as we explore the hidden world beneath the waves.
All right, listener, are you ready to dive into the world of marine biology? Stay tuned as we explore the incredible life that thrives in our oceans. We've journeyed through the water cycle, explored those hidden landscapes of the ocean floor, and even witnessed those dynamic forces like waves, tides, and currents.
It's been pretty incredible.
It's been quite the deep dive. But before we wrap up, there's one more layer I'm curious about. What about the life that exists in all of this water?
That's a great point. We've been so focused on these physical aspects of water, but, it's the life it supports that truly makes it so remarkable.
I'm picturing coral reefs, teeming with colorful fish, bioluminescent creatures illuminating the depths. It feels like a whole other world down there.
It is.
Where do we even begin?
Well, think about those different zones we discussed earlier.
Okay.
The continental shelf, the slope, the deep sea plain, and those trenches. Each of these areas has unique characteristics that support vastly different forms of life.
So the creatures living on that sunny continental shelf would be totally different from those in the dark, deep trenches.
Oh, absolutely.
Right.
It's all about adaptation. Life in the ocean has evolved in incredible ways to thrive in a variety of conditions, from the crushing pressures of the deep sea to the fluctuating temperatures and salinity levels we discussed.
This is where I wish we had visuals. I'm trying to picture those deep sea creatures, the ones that have adapted to survive in complete darkness and under immense pressure.
Right.
They must look so alien to us.
They do, and many deep sea creatures actually have bioluminescent properties.
Okay.
They can actually produce their own light. It's used for communication, attracting prey, or even defense.
Wow.
Imagine a pitch-black world suddenly illuminated by these flashes of light from these creatures.
That's incredible. It's a reminder that there's still so much we just don't know about the ocean, so much left to discover.
There is.
It's almost humbling.
It is, and the more we learn about the incredible diversity of life in the ocean, the more we realize how interconnected it all is. The tiniest plankton, for example, forms the base of the entire marine food web.
So those microscopic creatures are essential for supporting the larger fish, and then those fish are eaten by even larger predators. It's a chain reaction.
Exactly. And disruptions to any part of that chain can have these cascading effects throughout the entire ecosystem. That's why understanding these relationships is so crucial for protecting the health of the ocean.
This all ties back to the water crisis, doesn't it? It's not just about having enough water for humans to drink or to grow crops.
Right.
It's about ensuring the entire web of life that depends on water can thrive.
It is. And as we face increasing pressure on our water resources, it becomes even more important to consider the needs of, all those who share this planet with us.
This deep dive has been a real eye-opener. We started with what seemed like a simple topic, water, and we ended up exploring everything from the vastness of the ocean floor to these intricate relationships within these marine ecosystems. It feels like we've barely scratched at the surface.
We have, but I think that's the beauty of it, right? There's always more to explore, more to learn, more to appreciate about the natural world.
It's definitely left me with a sense of wonder and a thirst to keep learning. What about you, listener? What's been your biggest takeaway from this deep dive?
For me, it's a renewed appreciation for the interconnectedness of everything.
Yeah.
How the water cycle links, the smallest raindrop to the fastest ocean. How the forces of nature shape this planet we call home. And how the incredible diversity of life depends on this delicate balance.
It's a powerful reminder that we're all part of this intricate web of life and that our actions have ripple effects throughout the entire system.
So as you go about your day, consider the journey of that water you drink, the rain that falls on your roof, the waves crashing on the shore.
It's all connected. What a thought-provoking way to end our deep dive. Thanks for joining us on this journey. Until next time, keep exploring, keep questioning, and never stop diving deep into the world around you.